Hello students, in this video we are going to study the classical problems of synchronization. Okay, so now what is classical problem now? Classical problems of a synchronization. Clear? So there are these problems are useful in finding the solution to a large class of concurrency control problems. Okay, so these classical problems are going to be used as a test cases to test almost all newly introduced synchronization schemes. Okay, so now there are three synchronization problems, so these are very important. Okay, definitely you will get it in a exam for a 5 or 10 marks. Clear? So now there are three synchronization problems, or under classical problem of synchronization we are going to study the three classical problems. Okay, as you can see on a screen, so there are three problems: a bounded buffer or producer consumer problem. Okay, so then dining philosophers problem and the reader writers problem. Okay, so there are three problems: bounded buffer, dining philosophers problem and the readers writers problem. Okay, so all the three problems are very important for your exam. So first we will see the bounded buffer problem. Clear? So in bounded buffer problem, so already we have discussed this producer consumer problem. Okay, so I have explained the buffer sizes as a bounded and unbounded. Okay, so what is bounded here? So buffer is nothing but a temporarily we are storing the certain data or the information. Okay, then what is bounded here? So bounded buffer is what here? The buffer is having a certain limited size, and unbounded is we can store the data as much you require or you need. Okay, so there is no limitation in unbounded, but here in bounded buffer there is a limited size of a buffer. So now this problem is generalized in terms of the producer consumer problem, where as the name itself indicates here, the bounded buffer, bounded means, as I told, where a finite buffer storage or the pool is used to exchange the messages between the producer and consumer processes. So as we already studied the producer consumer problems in the third unit, so producer and the consumer are nothing but the two processes. Okay, or the inter-process communication processes. So now here the buffer pool is having a limited size or the finite buffer size. So whatever the size, but there is definitely a certain size is there. So hence the name is a bounded buffer problem. So what is the solution to this problem? Okay, so the solution to this problem is we have to create the two counting semaphores. So already we have studied the types of a semaphore. So in this bounded buffer problem we are going to study the we are going to use the counting semaphores, that is full and empty. So there are two semaphores, counting semaphores we are going to use. So why full and empty we have to use here as a semaphores? Because in bounded buffer, as I told, the producer and consumer are the two processes. So producer is going to produce a certain data. The producer process, it generates or it produces the useful data or the necessary information. So that the producer process has to produce the full buffers. Okay, for its consumer. So now what consumer is going to do? Whatever the data has been produced by the producer, it has to consume the data from the process called producer. Clear? So now here we are going to use the two counting semaphores, that is full and empty semaphores we are using, that two counting semaphores. So full and empty. So why we need to use full and empty here? We have to keep track of the current number of full and empty buffers respectively. So now before explaining the structure or the pseudocode of producer and consumer, you should remember here that whenever we are executing our concurrent execution of both producer and consumer process takes place by sharing a common buffers, so that can be filled by the producer process and we have to empty it or emptied by the consumer process respectively. Okay, so the bounded vapor problem makes use of a fixed sized buffer. Clear? So therefore producer process must wait. Therefore the producer process must wait if the buffer is a full. Okay, the producer process has to wait if the buffer is a full, because already the buffer is a full, we cannot generate here the what data, because there is no space to store that data. So similarly for consumer process, if the buffer is empty, we cannot consume the data from a buffer. Okay, there is no data in the buffer, so that hence we cannot access the data from that buffer. Clear? So these two conditions are very important. So hence the counting semaphores are going to use the two full and empty. Clear? So why we need to use the full and empty? So now on this screen you can see here there are two pseudocodes. There is a pseudocode of producer and consumer problem. So left side you can see producer and similarly a consumer side. So in producer we are going to produce the new resources, or you can say we are going to produce an item, okay, or data you can say. So now we have to wait for we are going to wait here. So already as we know that wait and signal are the two operations of a semaphores. So wait is nothing but what? It is going to decrement the value of value of an semaphore. And similarly signal, what it does, it is going to increment the value of a semaphore, that is S minus and S plus we have done. Clear? And when we are going to decrement the value of a semaphore, when the semaphore value is less than or equals to 0. Okay, means when it decrements the value of a semaphore, okay, if it is positive. So if S is a negative or 0, then no operation is going to be performed. Okay, so similarly, so now for producer process, just at left side you can see producer process. So producer is going to produce certain data. So now wait for an empty means what here? If semaphore value is if semaphore value is a positive, we are going to decrement the value of a semaphore. So if S is a negative, there is no operation is going to be performed. So what is wait here? Wait mutex. Wait mutex is nothing but a mutual exclusion. So why mutual exclusion here? As I told earlier, that when concurrent processes are going to be executed, means two processes are simultaneously executing the producer and consumer process. So in that case, what we are going to do for that purpose? So similarly, wait empty and wait mutex. So mutex is nothing but we are handling our mutual exclusion. Okay, if two processes are parallelly running, then how you can consume and how you are going to generate the data. Clear? So that's why. So now whenever you are going to produce the data, we have to add it to the buffer, or we are going to store it into a buffer. So how you are going to store that? By using the signal. So what is signal here? Signal is nothing but the one of the operation of a semaphore. Clear? So in signal operation, what we do, it increments the value of a semaphore by 1. Means already we have stored the certain data in the first slot of a buffer. So if we have produced the one more data, that also we need to store in a buffer. Okay, so that's why we need to increment the value of a semaphore. So hence we have to be we have to store that data in a buffer. So again here also signal mutex. So again here also a mutual exclusion is going to be performed. So at the end we are checking here the full. So as I told, if the buffer is already full, we cannot generate here the data. Okay, so this is how. So similarly consumer here, so same thing is there, but so now at the beginning if the buffer is a full, now we can access the or we can consume the data from the buffer. Okay, the consumer is a process is going to consume the data when the buffer is a full or when already a buffer is when certain data is present in the buffer. So similarly we have to check for the mutual exclusion, and similarly so whenever we are consuming the data from the buffer, so that buffer that data is going to be means that buffer has the empty space. So now we have to point it to a in that buffer space we can store the some other data, hence we have to remove the resource from the buffer. So once again signal mutex and signal empty we have to perform. So why signal mutex? Once again for the mutual exclusion, and similarly empty. So when consumer process in buffer is when buffer is empty we cannot consume the data from the buffer, so hence we need to check it. Okay, so this is how the producer consumer processes are going to be worked. Clear? So this is the bounded buffer problem in the classical problems of a synchronization. So to understand these all the basic things, first you need to understand the critical section problem. So if we have got the idea of a critical section problem, then only the third unit is going to be understood. Clear? You are going to understand when you are going to understand the topic critical section semaphore. Okay, so these whatever I am explaining in the last videos and even in today's video, these all are very important for your exam purpose. Thank you.